Alright, so let's practice some word problems here using inequalities. First we have a standard consecutive integer problem. We're going to find all sets of 4 consecutive even integers whose sum is between 3 and 28. So let's first start by identifying our 4 consecutive even integers. So for a problem like this, we always start with x. And because they're even integers, we go up by 2 each time. We do the same thing if they were odd integers. If they were just consecutive integers, we'd go up by 1 each time. Alright, so now let's figure out what their sum is. Just add up those 4 expressions. And so since the sum is 4x plus 12 and the sum is between 3 and 28, I will put it between in a sandwich type combined inequality. Between 3 and 28. Remember that between means not inclusive, so I don't include an or equal to. And now I just go and solve this inequality. And so when I solve, I get that x is between negative 2 and 1/4 and 4. And so I need to identify all the possible values for x. Now x has to be an even integer. So the first such even integer that would fall in that range is negative 2. That's between negative 2 and 1/4 and 4. Then I can keep on going. I could have 0. I could have 2. And I actually can't have 4 because 4 is not less than 4. So since that's the case, I've got 3 different scenarios. One where I'm starting at negative 2, one where I start at 0, and one where I start at 2. I can fill in the remaining 3 integers in each of those sets. And so you can see these are my 3 different sets. Negative 2, 0, 2, 4 have a sum of 4. 0, 2, 4, 6 has a sum of 12. And 2, 4, 6, 8 has a sum of 20. Those 3 sums are between 3 and 28. And no other sets of 4 consecutive even integers will have that property. So that's one example. We have 3 answers here. And we can move on now. Let's try another problem. Alright, our next problem is a bit of a geometry problem. So all 3 sides of an isosceles triangle have integer lengths. The legs, are both 2 inches longer than the base. What is the minimum length of the base if the perimeter is at least 33 inches? So let's start with a diagram. And there's my isosceles triangle. I'm interested in the length of the base. I'll call that x. And to show that this is an isosceles triangle, which would have 2 base angles that are the same and 2 legs that are the same, or congruent, then those are both 2 inches longer than the base. So I'm going to call that x plus 2 in both cases. Now I'm interested in the perimeter, so I'm going to add up all 3 of those. And since the perimeter is 3x plus 4, and it has to be at least 33 inches, at least means greater than or equal to 33. And now I just go ahead and solve that inequality. And so I end up getting that x is greater than or equal to 9 2/3. And since all 3 sides have to be integers, that means that the smallest possible base would actually have to be bigger than 9 2/3, which would be 10 inches. This, of course, would make the 2 legs both 12 inches. And we can confirm from here that that does in fact have a perimeter of 34 inches, which is at least 33 inches. So just by drawing a good diagram, we were able to get this. And one thing that's important to remember is we have to answer the question we're actually looking for. So what we're looking for is the 10 inches. That's kind of our key. And then one other thing I just want to point out, it doesn't become 10 because we're rounding up 9 2/3, because 2/3 would make us round up. It's rounded up because we have to be bigger than it. That's just an important thing to keep in mind. Even if it was greater than or equal to 9.1, it would still end up being 10. It's not really rounding, it's more comparing to the number. Alright, let's look at one more example. Alright, last example here. New gym costs $30 to join, then costs $15 for every hour spent with a personal trainer. Non-members can hire personal trainers for $19 per hour. What is the minimum time spent with a trainer to make the membership a better deal? So this is kind of one of our classic compare the plans type problems. So I'm going to first establish my plan for a membership. With the membership, I have to pay $30 up front and then $15 per hour, so I add 15x. Then I can look at the non-membership option. And that's pretty straightforward. It's just 19x because it's $19 for every hour that you spend with the trainer. And now I just want to compare these two. So if I start with the non-member and I compare it to the membership plan, now I have to figure out which inequality symbol I use. Well, I want to make the membership a better deal. So I want the membership to cost less. And so I'm going to use a greater than here because I want the membership here to be less than the non-membership. Now I'll go ahead and solve this inequality. So when I solve this inequality, I end up finding that x has to be greater than 7.5. Now, we're not actually given the information here about whether or not we have to hire the personal trainer for full hours at a time. Maybe half an hour increments are okay, maybe 20 minutes, 15 minutes. We're not really sure, but maybe we'll assume for this case that we need to have hour measurements only. So since x has to be bigger than 7.5, if we have at least 8 hours, that would be the minimum amount of time needed to make the membership a better deal. You could plug in, just to confirm that that is indeed the case, if you go 8 hours on each plan, it would cost a member $150, and it would cost a non-member $152. So you can see that that's where it's going to start to make a difference. So if you're going to have to be with a personal trainer for more than 8 hours, or 8 hours or more, then you might as well get a membership. All right, hope this helps with some word problems.